We are Group 1B, here to present a user interactive friendly wave on a string simulation. So let's get started. First, I will show you how our simulation works and what can you do in our simulation and what's in it. So let's go ahead and press start. Here you can see an interactive wave on a string simulation where you can change the tension to make the string go slower or faster. And then damping on the other hand, where you can make the string moves higher or lower. And the toggle button where you can change the ends of a string, whether you want it to be free ends or fixed ends. So in our next explanation, my fellow colleague will explain what these buttons do and how does it impact on a string.
Now, I will explain what is wave on a string. Wave on a string. In a physics, a wave on a string refers to a mechanical wave that travels along a stretched string or rope, typically under tension. These waves are classic examples used to understand wave behavior such as reflection, transmission, interference, and standing waves. Key characteristics: transverse wave. The displacement of the string is perpendicular to the direction the wave travels. If the wave moves horizontally, the string moves up and down. For example, the string on a guitar. When you strum it downward, the strings wave horizontally. Medium. The wave requires a medium to travel through. The wave propagates because tension in the string transmits forces from one part to the next.
Next, we will talk about the impact of tension on the string simulation. Tension. Effect on the wave speed. The wave speed on the string increases with higher tension according to V equals to the square root of T divided by U, which the T means higher tension increases wave speed, where the higher U is a heavier string slows down the wave. So increasing tension makes the wave travel faster along the string. As tension increases, the wavelength stretches. The wave also becomes less curved. The slope of each part is gentler because the string resists bending more under higher tension. Higher tension often leads to higher frequency standing waves when the ends are fixed. Next, let's talk about the impact of damping.
Next is damping. Damping controls how much the wave loses energy over time, typically due to friction or resistance in the medium. With low damping, waves persist longer and maintain their amplitude. With high damping, the wave's amplitude decays quickly and the string appears to settle down faster. At very high damping, oscillations might not occur at all, or only minimal motion remains.
Now let's talk about the impact of fixed and free ends.
Lastly, fixed and free end. Fixed end force the wave to have no zero displacement at the end. Free end allow displacement at the end, changing the boundary condition and resulting standing wave pattern.
That is all for our presentation. Thank you for listening to our Wave on a String user interactive friendly simulation. So that's all to our user interactive friendly simulation. Now let's ask you guys, what's gonna happen if we slide the tension down and what's gonna happen when we slide the damping up?
So, if yung tension is ibababa, yung wave are bibilis or tataas. So, kapag ang damping naman ay nakababa, ang chance nun is babagal yung wave. Yun lang po yung sagot ko.
Precisely. Also guys, one more thing. What can you recommend to our simulation?
Legacy.
Slide that, slide that, slide that, slide that. Slide
You
that.
can press it.
Slide it, slide it.
It's not working.
Toggle, toggle. Okay, press that.
Oh, press.
Face
That's
dance.
not press that.
I have one recommendation for this.
What? What is that?
It's more real life, real life example. Because how can we know? Yes. Yes.
Ooh.
This word, real life example, like a weight and string, like up and down, up and down.
That's crazy.
You can use each one in Java for it.
Thank you guys. So, thank you guys for your cooperation.
Thank you guys.
Thank you very much.
Yes.